Hello everyone, my name is Priyanshu and today I will be explaining insertion sort. So the main core logic of this insertion sort is to take the element and place to its correct position. Okay, take the element and place to its correct position. So I will be explaining through an example. So in this example, initially we have the array this. Okay. So now what we have to do, we have to just iterate from the 0th index to the last index. And in each index we are where we are standing. Okay. Suppose initially we are standing at 23. So what we have to do is to just from the current standing index to the very first index to the very first left index, we have to just go from the current to the very first or the very left index and just check if the left index is greater than the right index element. So we have to swap it. Okay. So for example, initially we are standing at 23. Now we don't have any left element because it is the left element, so no need to swap. So it's 23. Now in the first pass. So basically we are saying that it's first pass because no need to check the 0th index because it doesn't have any left element. So that's why here is it is written first pass. So in the first pass we are at 1th index. Now from the 1th index to the very left index, we will iterate from the current to the left index and place this 1 at its correct position. See how? See 1 and 23. 1 is less than 23, but it's at the index where 23 is a previous element, because but what should be the correct order? 1 should be standing before 23, so we will just swap it. So we can see the result, 1 is before 23. Next, our index will be at second, our element will be at second index. So what we see here, we have to know from the second index, from the current standing index, we have to go to the extreme left and check if the order is not maintained, we will swap it. Now 10 and 23, we will swap it, and then again this 10 and 1, it's correct. So we can see up to the current index all the element are sorted after performing the pass. Now in the next pass we have 5. So here we can see we have to now go from the current standing index to the very extreme left, checking if all the elements are correctly placed. So if they will be not placed correctly, we will just swap it. So 5 and 23 we will swap. So similarly, after doing all the operations swapping, we can see 5 will be at its correct position, and we can see here 5 is at correct position. Now our iterator is at its last index. Now from last, now again we have to travel to the extreme left. Now what we will do, we will just to again ensure, we will make ensure that the left element is the left index element is smaller than the right index element. If not, then we will swap. So again, checking 2 to the extreme left, we will make ensure that 2 is at its correct position. So now finally our array is sorted. So the main core logic was to go from the to iterate the whole array from 0 to the last index and place that current index to its correct position by just going to the extreme left and keep swapping if the correct order is not maintained. So this was the main logic. Now I will be going through an implementation. I have used GFG portal. Now what we have to do, first of all we should declare the size of the array. Okay, now we will run the first loop which will start from 0, and we have to iterate the whole array. So the last index will be n minus 1. Okay, now the inside where we are standing, we have to go from the current standing index to the extreme left. So and checking that the current index element is at its correct position. So let's mark the current index as j. Okay, now I mean the current index is I, and now we have to iterate from the current to the extreme left. So we are using iterator j. Now while j is greater than 0 and array of j minus 1 is greater than array of j, so what we will do, we will just swap it. Okay, we will swap it and j will decrease. So this way we are checking array of j minus 1, which is the left index, if it's greater than the current index. Now we will swap it because we have to maintain the order, and we will decrease j, and we have to ensure j is greater than 0, because suppose we are standing at the 0th index, then how can we check the left element? That's why we are marking here j is greater than 0. Okay, now we should check it whether it is running correctly or not. Okay, it's running. Now let's submit it and check whether it is able to pass all the test cases or not. Okay, our problem is solved successfully. Now if I talk about the time complexity, it's big O of n square, clearly we can see, because here we are using two for loops, one for loop and one while loop. In the worst case, the j will be the last element, n minus 1. Okay, and we have to go to the extreme left, so both loops are running n times, so we have time complexity n square. Now what we have to do, if I tell you about the average case and best case. Average case and worst case, we have O of n square in average case and worst case both, and in best case we can see our time complexity if big O of n. See why? I will explain you. We can see here that suppose our array is already sorted. Now this inner while loop will not run, because see, if we are iterating from I is equals to 0 and we are making ensure that every element is at its correct position, so if the array is sorted, so the inner while loop will not run and only the outer for loop will run. So uh, we can see here that it will take in the best case only big O of n. Okay, and if I talk about the space complexity, it's big O of 1 clearly. So if I tell you one thing more about it, It's an stable sorting algorithm. It means it maintains the relative order even after sorting. So this was all about insertion sort. Thank you.